Hi, welcome to my presentation Unlimited Sherlock Deep Dive into Forensics Operations to Track Down Hackers. As you can see on the slide, my name is Paula Januszliewicz, and what I'm doing for a living is pretty straightforward. I'm engaged in cybersecurity for over 15 years right now, and I'm the CEO of Secure. This is the company that I have established 13 years ago. And basically, our company is right now spread across four locations. So New York, Dubai, Zurich, and Warsaw in Poland. And we are a pretty big team right now because it's over 40 people dealing with cybersecurity issues. And at the same time, I'm also a Microsoft Regional Director, not working for Microsoft, but I am having this honorable title because Microsoft, well, first of all, gave me, and second is because I am happy to convert technology into something innovative. And at the same time, I do have access to the source code of Windows, and that's something that allows me to do a little bit a deep dive into how we are able to understand mainly Windows security and eventually what kind of things we are able to do in order to improve it. It's not 100% of access, it's like 99% of access, but it's still something that gives the possibility to conclude what's going on. Well, I'm also engaged in speaking at various conferences. I've been delivering the keynote at the RSA conference in San Francisco, the biggest technological conference in the world. And also, I've been rated number one speaker at Black Hat and also at Microsoft Ignite. So, technically, as long as, of course, there is someone to listen to what is happening within the cybersecurity world, I'm always happy to share insights from the practical field because my background job is, even though I got a business role at the company, is to deliver penetration tests and also incident response and forensics projects. So this is what I've been always doing, and this is what I'm doing till today. Within our team, of course, we deliver this kind of projects, so it's something that our customers are coming to us when they got an attack, and our job is to react to that incident. But not, of course, only this one. We also design cybersecurity for customers. So it really depends who we are talking about. If it's about our whole team. So why forensics is so important? Because we are talking here about the different deep dive forensic techniques that are allowing us to find hackers. So why this is such a hot subject? Well, first of all, we need to know that digital forensics, it's a term that is increasingly popular within the cybersecurity sphere because we are dealing with incidents, and we have to know basically how not only to react to incidents but also how we are able to learn what happened. And forensics steps in at that moment where we've got, for example, malware that was causing a certain drama to happen in the infrastructure, and our job is going to be to simply take that malware and investigate, put it into the context of the infrastructure and learn where malware potentially could act and what was the scope of the attack. And if it's about the inside of the malware, what kind of activities it did in order to break into our infrastructure. So that's basically, in short words, why forensics is such a hot topic. Another interesting perspective over here is that forensics itself gives you the idea, the picture of what happened during the whole attack. Sometimes you're investigating Windows boxes, Linux boxes, and you're extracting as much information as you can in order to understand what kind of impact hackers had after the attack. So when we take into consideration some interesting statistics, and this is actually coming from the Verizon's 2020 Data Breach Investigations report. I really like Verizon's report because they're very informative. This time they said, summarizing 2020, of course, 2021 is going to come. Yeah, so that's why we got statistics from the past year. Here we are able to see that 70% of breaches were caused by outsiders. And I would say not a surprise, because when we take into consideration some other reports, we are able to see that phishing is actually a number one mean of transportation for malware, and it's also a number one thing that is happening that is actually causing the attack within the organizations. Also, when we take into consideration that 86% over there, we can see that that amount of breaches were financially motivated. Exactly. When you got a successful ransomware campaign, when you got a successful attack, we are here getting into the sphere of human operated ransomware and so on. So when the hackers are already there, they manage to attack the organization, then they are figuring out what to do. And one of the things that they are deciding on is actually data encryption. So it means that our data is at risk and we are trying to get it back by, for example, decrypting it either because we pay, who knows, or another part might be we are trying to recover it from the backup. So unfortunately, and this is what the experience shows, quite often companies, they do not have well designed, well tested backup strategy. That's why these breaches are more and more popular, and there are more people stepping to the bedside in order to get a bit of an income from the well-established ransomware campaigns. When we take into consideration campaign like that, hacker can earn approximately $90,000 per month on running it in a good way, so that it hits the certain targets. They do indeed do not have a good backup strategy, and that's why they decide to pay. Which, of course, we all know that it doesn't always mean that they're gonna get their data back, but that's the background. So when the attacks happen, what is important for us to know is that moment where we discover it is a quite a happy moment, right? So there is actually an interesting set of statistics shared by the James Comey, the former FBI director. Well, he says that when the hackers come in, they do sit in our infrastructure for approximately 200 days. So that is quite a serious number, isn't it? So imagine that hackers are in your infrastructure for that time, and then you discover it, and then you realize that there's nothing really to recover because they've been like everywhere, and they've seen like everything. So 80 days. It's also measured here after detection to full recovery. That is also quite an interesting statistic because it shows that when the consultants come over, because usually companies do not have an in-house skill set to recover quickly to bring them back to the operations, then which is also making it quite an expensive situation. Then it's 80 days needed until the company is like, okay, now we are all good. Now we're all set. We have recovered everything. We have all the services that are working properly, and so on. So that is what we see. Now, just to share a little bit of a story before we get into demos, during the pandemics, we've been actually participating in a very interesting project where the customer, which was international customer with a series of factories all around the world, they got fully encrypted. So they got ransomware. That ransomware got into their network by leveraging vendors relationship, meaning that they were supported by certain IT company and hackers knew that, and that particular IT company got hacked, and then hackers managed to get credentials that apparently they were using over there, and then access the particular organization. So it's also quite interesting to see that vendors are put into the context of the whole attack paths, and they're actually becoming one of the attack vectors. So that's why when we are a big organization, one of the things that we should encounter in our process, it's simply the verification of who is our vendor and how do they manage our credentials. And also we should, on our side, assure that they're not just logging on with the username and password like it was in the case I'm explaining, but also that they are using, for example, multi-factor authentication and so on. And you got a full control over how not only that identity is used, but mainly where it's used. So these consultants, they are usually not getting into these servers, but now they do. Okay, let's figure it out. So that kind of intelligent threat detection is something that is definitely needed for the current times in order to not only investigate, of course, what happened, but mainly to prevent. But when we don't have a prevention, then attacks happen, and in this case of this customer, we could observe that their infrastructure was attacked. Now, they actually paid and they negotiated with the hackers the certain price. There was a company that was especially hired for that, for the negotiations, and they have negotiated €500,000 to pay in order to get their data back because of the poor backup strategy. So what they got as a response was actually a decryptor. And imagine, guys, that decryptor was not working. So you can totally put that into the real life, that you actually pay a huge amount of money for something that just simply doesn't give you anything. So that's quite a big disappointment. But they were claiming that it's supposed to work. So where is the problem? So what we did, we have decompiled the decryptor. So we kind of were playing the role of a help desk for hackers, to be fair, and we decompiled it, and we learned what are the algorithms used, so how they are actually used. Well, algorithms is one thing, but how they are used, also where are the keys, and so on. So we managed to totally put that into pieces. We built up our way to decrypt the data, and we manually decrypted the data that was there encrypted. So luckily for them, it all worked fine, but it was a pretty expensive situation to deal with. Now, how did we learn that it was actually from the vendors network? So one thing we always have to take into consideration, that whenever you are doing the investigation, even though hackers might clean up their traces pretty nicely, then there's always something that you guys are able to find. Always something. And that is also something that I would have to share with you. First, let's start with the memory. Whenever we got the memory dump made. After the attack, you've noticed that there is something going on, you start the incident response procedure, and then one of the things that are actually part of that is collection of the evidence, memory, and both the disk. So first you do the memory, then you do the disk. You do the memory dump, for example, with the FTK imager, or with Dumpit, or Belgasov RAM capture, or Memorize, or whatever. Yeah? So there are many tools that you could use for that purpose. I'm a big fan of Dumpit and also Belgasov because they are tiny. FTK, of course, it's a good tool too, but these two are tiny and they're pretty quick, and they just give me what I want very quickly while we are collecting the evidence. So when we are thinking about memory, so what is interesting within the memory? And this is something that I would have to start with in order to show you a couple of things for now within the demonstration. First of all, we're going to be using over here the volatility. So that's the one that we are able to play with while performing the analysis of the memory content. So when you make a dump already, volatility is playing a really good job over here for that one. And I got a volatility over here. So that's the volatility master. And one of the things that I would love to run over here, it's going to be the volatility itself. So let's just figure it out. I got here the vol py, fantastic, and that's the one that I'm going to be leveraging. So we got a vol py, our volatility, and volatility itself will allow us to jump into the memory content. So volatility py, and then we're going to use it, for example, with the parameter of f for file. And then in this case, we're going to be getting into the discovery of the hidden process. So here we're going to use the -f for file, and then we are getting into the d, and in this case, it's going to be tools. And then we got dumps, and then we got over here the analyze.dmp. And that analyze.dmp, we're going to run with the profile of, in this case, it was Windows 7 SP1x64. And then we're going to run over here the PS list. So PS list allows us to list, and let's make it prettier, to list us processes, of course, very quickly. And this is the query of something that we call active process links. And active process links, it is actually a structure that you can cheat on if you would like to simply hide a process. Hiding a process is part of the DCOM technique, so direct kernel object modification technique, that is usually used by rootkits. But what I would love to show you is how easy it is actually to find it. So if the process is going to be hidden because someone's going to modify the active process links, then we are making the memory dump, and then we're like, let's see what we got. And here we don't see really much. So there's an SVC host, there's an explorer, there's an emmet agent, and all that stuff. So long story short, what we can do, we can also do the PS scan. And PS scan runs a little bit longer. In my case, it was actually pretty quick because my memory dump is small and I've got lots of memory, and my memory dump is all loaded into the memory. That's why it's so fast. So here you are able to see that we've got an additional process, which is called malware.exe. And that's the process that we couldn't see before. Now, the PS scan, though, is actually relying on the eProcess structure as well. But here we are able to find, also based on handles, to various processes from client-server runtime subsystem, what kind of processes here are hidden. So client-server runtime subsystem, summarizing, is actually the guy that not only manages processes, but it also assigns resources to them. Meaning, if there is something that is there using resources, and it has to because that's basically how the process structure looks like, then we are able to find it through many different ways, really, not only getting live to the system and checking the handles, but also we're able to make a memory dump and check it like that. So what I'm trying to say over here is that systems simply do allow the modification of the process list. So in this case, in Windows, we are able to analyze and mainly edit the active process links list, but we are also able to discover it because processes, they have to get resources, and that is also one of the ways to spot them. So things cannot be hidden, really. I mean, it's sometimes hard to find them, but they cannot be hidden. So here we go. We've got one thing. Now, second thing around memory that is not trivial that I would like to show you is related with the memory dump analysis from the file extraction. So imagine one thing over here. Our job is going to be to right now extract the event logs from the memory. Which event logs? The ones that were processed at that time by leveraging the event log service. So if there is an event log service working, it's working on logs, then maybe the log technically was cleaned, but there is still something within the memory that service was working on, yeah, and so on. So you would like to technically make a memory dump, and from the memory dump extract the logs. Or the only thing you got is just a memory dump for the analysis, and you were like, let me just extract as much as you can. And why you want to extract event logs? If they could contain information that is eventually useful for the projects, you would not avoid that, yeah. So you would rather step into any possible extraction of information that you would have in the memory dump. So anyway, within the volatility, we will be actually getting into this point. But first, if we would like to extract the memory, the content of the memory, and especially the event logs, we need to figure out where event logs are stored. And they are stored and processed by the event log service. So what is event log service? Well, that is actually the SVC host. So if we do event PS list like this, what you're going to see is that we've got a bunch of SVC hosts over here. So which of these is actually running the event log service? We can't say. So that's why what you guys have to do, you have to leverage again volatility, but from a different perspective. We're going to list over here the DLL list, and we're going to put it into the text file, so dll list.txt. Why we're doing this? Because we want to find SVC host that is actually loading the Windows indexing service, not Windows indexing, but Windows event log service DLL, and that's the one that we're gonna be getting to. So that's actually the Evt svc.dll. So yeah, let's have a look. So we're gonna do DLL list, and we can open it up like that. And what are we looking for? It's the WEVT, not API, but SVC, yeah, that's correct, in the SVC host. So we found it. That's actually the process ID 848. 848. So what we're going to do now? Now we're going to do the similar command, but we're going to dump the files that are inside that SVC host. So we're going to also rely our search on handles. So here we're going to do profile, like you already know, but this time we're going to do dump files -n -p. So this is to preserve the name from the process ID that we were playing with, and that's our 848. 848. So here we're going to use the 848. Yeah, and then pretty much I would say that's it. But one more thing we could do over here, we could actually store it in the particular directory. So that's going to be within the Python over here. So we could store it within the directory that we can technically set up over there. And that could be, I'm going to create a directory over here. Let's say dump. Here we go. Yeah. So we've got this one, and we just name that particular directory dump. Yeah, so this is the one that we store over there. Or we could actually, let's just do it this way. Here we go. It's going to be the folder. Yeah. So here we go. So eventually, after some time, we can see that there are Evtx's coming out, and that's awesome. But the problem with the Evtx files is that they're very sensitive. And for the fact that they are sensitive, it means that they're going to be most probably broken. So if we are about to analyze what kind of things we got over there, let's go to this dump folder, and I'm gonna do it in GUI, why not? And within this dump folder, you guys are able to see that we've got lots of VACB files, VACB and so on. We're gonna search for application. Yeah, so here we go. And we're looking for the application log. That's gonna be this one. So I'm gonna copy that log. And what I'm gonna do, I'm gonna paste it in the analysis folder that we're going to be leveraging right now, because that log I already know it is actually broken. Yeah. So having this in mind, we're going to be playing with the Evtx Recovery, and that's actually pretty awesome because Evtx, as I mentioned, is a pretty sensitive piece of file, and that tool that I will show you, you are not only able to use for the memory extraction, but you are also able to use it while you've got an issue with your Evtx file. So we actually wrote a tool that is fixing the Evtx files, plus we made a reverse engineering of the Evtx format. It took us over half a year actually to do it, because Evtx is very difficult, but it's good to know finally that we are able to fix these files. So what we're gonna do, let me go to the D drive. I'm gonna clear the screen, and then I got over here the path to enter, and over there I got two folders. One is called in, and this is where I have copied our application file, and another one is out, which we can of course check, and you can see it's empty. So it's easy. Okay, so let's clear the screen. And then what we're going to do is a CQ Evtx recovery. We're going to do the recovery for input folder, for output folder. So we managed to recover 17 records. Good. But why we're actually recovering it? Let's go to the in folder to compare basically these files. First of all, we've got over here this, let's check again, file Evtx VACB. Yeah, so we're going to do rename file into file but Evtx so that it normally opens. Okay, so let's see whether we are actually able to open this particular log. And it actually opened on my screen over here. So that's this one. Yeah, as you can see. And it says it's corrupted. Yeah, it is totally corrupted. So if we won't like to play with it, we cannot, because eventually this is this event log that is just simply broken. There's lots of digital signing inside, so that's why we're not really able to make it easily to be opened, because of the various chunks and single entries that are digitally signed and so on. Yeah, so this is quite clear. Okay, lovely. So the next part over there is going to be to fix it. Yep. So I can just close it, and then fixing it already happened. And eventually we can go to the out folder, and then over there we've got our Evtx file that we are able to open, and then that's the second one that is opening over here on the top of the broken one. And then in the moment, because we are verifying the digital signatures over here, it's going to show us a couple of events. It is not 17 events as it was written in the console, because it's more chunks that we are referring to. These chunks make events, and this is what we are able to observe as well. So yet another interesting tool that allows us to learn that that what was happening right now in the event logs, it's in the memory, and then maybe that could help us out to investigate more of an issues. And actually, I'll tell you one little detail here is that that tool was actually written in the project where we had to extract Evtx's from the memory, because there was a case of a hacker that was sabotaging the network. So there was like a factory again, so different one, and that particular admin was actually putting the various services down, and then our job was to figure out that that's this guy actually doing this. And one of the things we had to extract from the memory dump that we had from his laptop were actually event logs. So that tool, proven already, that is very useful in the practical project. Yeah. Okay, so we've got that one. Now, within the memory, of course, we could be talking about that for hours, and memory is a huge subject that is full of interesting ways to extract information because quite often information isn't really integral, so you have to do something to work on a file, to work on information in order to make it work for you. But I think that this perspective also shows us that there is this possibility, and not only we're able to find things that are hidden in the operating system from the memory dumps, but also we are able to extract sometimes things that are pretty much or were pretty much not that easily recoverable. Like for example, corrupted EVTX files. EVT, it's simple. EVTX one, no. So here we go. Okay, guys, so what about the next part? The next part that I got for you is related with extracting information from the disk. And there are so many things that we can have a look at. And to be fair, disk is also quite rich. It's a little bit simpler than memory, at least in my opinion, because you got more tools to work with and you can pretty much almost immediately get some kind of an insight about what is going on if of course you're going to use good tools, if you're going to use the good tools. Now these tools sometimes you might be writing in house, but sometimes you might be using the tools that are either written by community or commercial and so on, but eventually there are certain places always to look at. And this list that you can see over here, it's this good list to start with while you are performing the disk analysis after you make the disk dump. And one of the things that I really like is, and that's not very obvious, and we are talking today about, or trying to talk about the not obvious things, that's actually automatic destinations. And the reason why I want to show you these ones is because they are rarely appearing in forensic books, to be fair, and automatic destinations are representing a somewhat cache that is used by applications. If, of course, applications are written in a certain way, so there are many if, but on the other hand, when you are using the software that is publicly known, so things like Office package, so Excel, Word, if you're using Notepad, if you're using any PDF readers, and so on, then outside of Microsoft, of course, then you are able to most probably find quite a lot of information about the application's cache. And what I've got over here is something that's called Structured Storage Viewer. This is a very simple app that allows me to get into the automatic destinations. If you are thinking about where are they, they are actually in the users folder. So you are able to find them in the C users, username, app data, roaming, Microsoft Windows, recent, automatic destinations. This is also a hidden folder, so you have to get there directly. And over there, we've got two files that are suggested to be open. This 9b90, it's actually something that if you go, for example, to Forensic Wiki and you search for automatic destinations or jump list, as we sometimes call it, and you search for jump list, JMP list IDs, then you are able to find lots of commercial apps represented by identifiers. This identifier is actually the one that represents Notepad, 64-bit Notepad. So if we do open it up, and I open the second one, but let's go for this one, then anything you click, by the way, is actually showing us particularly a text file that has been ever in this Windows installation opened. So imagine that in your organization you're running like Windows for like 2 years, then you're gonna have over here the 2 years history of anything that has been opened. So imagine that that could be really useful while you are investigating, for example, if user had access to this data and so on, and you don't have a tracing maybe set for various data repositories. Therefore, from the Windows box, you are actually able to learn that information. So here, for example, let me enlarge this. We've got the structure number 10. The tool is not the most user-friendly tool, and Eric Zimmerman is also writing a good tool so that there's like a jump list explorer, and both of the tools are really good. Yeah, so here we go. So here you are able to see that there is Python 27 volatility master DLL list. Perfect. So this is the file that we've been working on today, right? So And if you go like file by file, structure by structure over there, you're going to see the whole list. Same happens for Office applications, for example. Now, I've been participating in a project which has a very sad background because it was related with the childhood pornography, where the person who was involved in the crime was deleting lots of things from the computer, and the computer supposed to be clean. So after the collection by the certain unit, the disk was sent to me, and I was supposed to analyze that part. And there was lots of things that were not there, basically. But what was there is actually there was actually automatic destinations, and I was digging into automatic destinations for Windows Media Player, where I was able to see that there were certain indicative titles that were suggesting the crime. Of course, it's not an evidence because it's not digitally signed. You're not able to really assure that that content is what it is, but it is already some kind of an indication that there is more definitely to search for. And that was also playing a crucial role in the case because you were able to see that, this is how this mechanism works within the Windows Media Player. These were the titles that were open in connection with the data chunks that we were able to find on a disk, and so on. Yeah, so there's a plenty of things behind that that are allowing us to trace and search for a little bit more information from the drive. Okay, so what else is there? Well, basically within the disk, we can find, of course, more information like Windows indexing service. You can also find deleted files that you are able to recover. You can also play with the metadata and be able, for example, to search within the USN journal whether the metadata has been changed or not. Yeah, so in general, when you've got a file, for example, that is claiming that it has been, let's say, created 3 weeks ago, and then you can always verify that within the FSUtil and USN read journal, and then you can see that, not really. For this file, there was a metadata being changed. So this file, it's really from like 1 day ago. Yeah, and so on. So we've got these kind of possibilities. But I would say that that's quite obvious in some sense because it's a typical list of steps to do while we're doing forensics. What I would love to show you is actually quite interesting setup for something that we call data protection API. And data protection API is actually a cryptographic platform that we are able to play with in Windows that allows us to store data for various users once, of course, users decide to store them. So if you've got a situation that you've got users that are, for example, storing passwords in the browser and so on, that is exactly that we want to see over here. That within such an approach, you would be able, for example, as a hacker, to extract the passwords from browsers of the users. But of course, everything has to happen like within the attack under certain conditions. So if you store a password in a browser, if you store a password in Outlook and so on, then these passwords are obviously, when you open Outlook or browser, in use by yourself. And that is something that it will be lovely to talk about. So data protection API is a cryptographic platform in Windows, and you are just using it by default. And I'm not saying at any moment it's bad. It is actually a good solution, but it has certain situations that you guys need to know about. First of all, let's get into the demo. So here we've got a Freddy Krueger, and then Freddy is trying to log in with the password. Okay, so that's it. That's Freddy's password. Freddy has access to the domain, so we are actually logging onto the domain. Freddy is not offline, so this is not a cache logon, data login, and so on. So we just log in. Okay, Freddy, by the way, has no access here to the internet, so that's okay. Only, yeah, exactly. That's why. So only to the internal infrastructure. And over here, we've got a situation where we are able to eventually search for the password that Freddy has stored in the browser. So that's Chrome Pass. And here you are able to see that we've got a password like this. And why we can open and extract the password from Google Chrome in a Chrome Pass, because this app is running as ourselves. This is the rule that we should definitely remember, that if you run things as yourself, you got access to all the things that obviously you have stored. So if the hacker within the phishing attack is running its code as that user. So then we got access to lots of credentials that potentially user might have stored in a desktop. That's why within the organizations, what we always recommend is the implementation of the password managers, which sounds like a default choice right now, of course, but not every organization is actually there yet. So here Chrome Pass. Okay, so yeah, if I'm Freddy, I'm logged in with the password, I'm able to see the stuff that I've stored in the browser. Now, question would be a different thing. Under which condition I'm able to see Freddy's credentials, Freddy's password stored in a browser if I'm not Freddy? And answer to this question is very simple. I have to know, of course, Freddy's password, so then I'm Freddy. But what is the other option here? The other option is that if the Freddy is a domain user, then I have to have a certain certificate from the domain to be able to read Freddy's passwords. And this is something that I would love to show you, because when the domain is under attack and we've got customers that they were completely smashed and hackers managed to be domain admins and so on, then you cannot, by all means, regain trust to the infrastructure because of this simple thing that I would like to show you. Of course, you can have a great monitoring and so on, but there is always the possibility to get access to the credentials of all of the users in the infrastructure if you're going to get that certificate. So first of all, let me cause a situation where we are not acting as Freddy. We're going to be acting as someone else, or we're going to be acting here as maybe Freddy, but we're going to present a different password. Okay, so this is basically to show you that if we do not know the password of Freddy, the correct one, so the password, then we will not be able to get access to Freddy's secrets. So what I'm going to do in order to achieve this situation, I'm going to simply, in this place, disconnect this machine from the network totally, and I'm going to log in with the cache logon data. Okay, but first, let's update cache logon data in order to be able to do that. Some people call it cache credentials. No, that's a very bad thing to call it because these are not credentials. We cannot log on with them. So please don't call them credentials, and I will explain in a moment why. So here we're going to get into the D drive, and let's go to the CQ tools. Let's go to the Kiwi Secure Edition, and over there we've got Mimikatz, and over here we all know Mimikatz, but this is actually our Secures Edition, originally written by Benjamin Delpy, of course. We have modified that with the module that allows us actually to do that, plus this version is not recognized by antivirus, so it's not too bad. So we're gonna get into the LSA dump, and then cache. And then we're going to override the cache logon data. So it's a Windows System 32 config. I have to type the whole thing, system, and then Windows System 32 config security, because this is where the cache logon data is, /kiwi, and eventually we are overriding at that point the cache logon data. So LSA dump cache, and then we've got a system and security. System for the boot key, security because this is where the cache logon data is, kiwi to override it. Done. So the next part, we are just rebooting. Now, using this opportunity, I'm going to explain what the cache logon data is. So cache logon data, it's nothing but MSDCC2, that's how we call it, and it's a result of a function which we called pbkdf2. And part of that function is actually username. Here we go. It is hmac schwa1, and so let's say it's like a random value. It's working on 10,240 iterations on 16 blocks, and it's leveraging as well the DCC1 value, which I have to explain. So DCC1 value, it's nothing but MD4 on the top of the username, joined with the MD4 on the top of the user password. So this is like two dimensions that we are struggling with in order to get access to the user's password. Can you brute force it? Can you crack it by using the rainbow tables for DCC1? Of course, but what about DCC2? It's quite a complex value, and DCC2, by the way, is used by Microsoft since Windows Vista, including Windows Vista. So it's a pretty good value that's stored within the registry that you cannot log on with. So that's why we're not calling it cache credentials. We actually call it cache logon data. So we only compare with it. why and how, let me show you. So here Mimikatz is going to be our password, but first let's try password that we had. Nope, doesn't work. And we are comparing right now with the value that we stored within the registry, within the Mimikatz when we were offline. You could also do it online, by the way, so both of the ways would work. Mimikatz, enter, we're logging in. So now our job is going to be to check if we do have access to the password while we log in with a different password of a user for the domain account. And the Chrome pass is trying to decrypt the master key that is responsible for protecting that password in Google Chrome with the current password hash, and it cannot because that master key is encrypted with the previous password hash, actually with the MD4 of the user's password. So how we are able to get access to this password? Haha. And here's the thing. Each of you guys, you've got in your domain very interesting thing. And that's this certificate that I would love to show you. And that certificate, let's make it a full screen here, is actually something that we are able to extract from the domain. So over there, I'm going to go to Tools, and then CQ DP API export PFX from ID. And over there is a CQ ELSA secrets dumper where we specify file exported PFX. We have, by the way, reverse engineered fully data protection API. Absolutely not bragging about it, but as far as we know, we are the first and the only team who did that. So who put DP API into pieces, and we wrote over 40 tools to support that. So we are always sharing them with you. Also, you will find a link at the end of this presentation, including this tool. And here we have exported a PFX file, which is stored where? Well, in ntds.did, but not really logically seen as PFX. It's just like a blob. So let's have a look into this one. So we got an exported PFX. We can import it. Next. Password, it's going to be secure, as you see. Here we go. Next. Okay, and the next part we are able to see is the cert mgr.msc, and then personal certificates. That's the certificate that each of you got in the domain. So it's issued by nobody, by nobody. It's already expired. You cannot renew it. There's nothing you can do about it. And when it leaks, you cannot renew that too. So when it leaks, you get a big problem because then it leaks forever. So then when it leaks, what does it mean? Let's have a look in here. It means that at that point, and let's start the console, you are able to get access to the user's secrets across the whole domain because this PFX decrypts secrets of every single user in the domain. So let's see how we can achieve this. First of all, I'm going to go to the DP API toolkit and I'm going to search for the master key that is responsible for Google Chrome for the password protection. So it's going to be the directory, C, Windows, not in the Windows, it's going to be users, of course. Users, Freddy Krueger, app data, local profile over there, and then we're gonna go to the Google, and we're gonna go to Chrome. Here we go. We're gonna do the recursive search output to the folder C. Let's just use the default CQ tools, and then we're gonna stream it to dpapi.txt. Enter. It's gonna take us approximately 20 seconds to do it. So if we go to the dpapi.txt, then immediately we see the master key identifier for the Google Chrome, and that's B55. By the way, Google Chrome underneath uses SHA-1 and triple this. Okay, so B55 is the one we are looking for. So we can get into the user's profile. So it's going to be %appdata%, and then we go to Microsoft, Protect, SID. These files, by the way, are hidden and also system files, so you have to show them. You have to uncover them. And then in here, that's B55. Okay, so shift right click, copy as path, and then over there, we're going to be playing with that decryption. So please have a look. First of all, we're going to use here the CQ hashcalc Mimikatz 1. That's my current password hash, so it's an MD4 that matters. And now we're using the CQ master key 80 file. That's this B55. We've got over there the old PFX, so that's the one that we got from the domain. And then we've got over there the new hash, which I can copy now and paste. So new hash, and we got it. Awesome. Perfect. So now what happened is that we've got a new master key generated. That's this 80 modified. So we're going to take this old guy and then rename it good. And then this 80 modified, and then we're going to name it like this. Yeah, so here we go. This has a blank console, so the only thing we will need to do is to give it an attribute of system and hidden. Enter. We got it. Enter. And then over there, within the moment of a second here, you are able to see that we've got a password to the user. That, by the way, certificate gives you access to every user password in the domain. So that's actually pretty serious. Plus, what we need to do is to review the permissions for the domain of replicating directory changes and replicating directory changes all, because these are also the ones that are allowing us to extract that kind of data. So the question is, how we are able to find or to understand hackers' activities? And answer is very straightforward, only by knowing more. So the more we know how Windows internals, Linux internals work, the more we understand the dependencies in between various mechanisms in operating system. Like, for example, finding this event log service, SVC host, WinEVT. So these are the things that we are looking at. Or here, data protection API, we're wondering, could hacker have access to credentials of that user? Yes, by, for example, stealing the profile information and then decrypting that password by leveraging that domain certificate. So there are so many things that can happen within the domain and within the infrastructure that sometimes, and that's our experience, we might not be aware of because they are not an obvious things to know in forensics. Forensics is one of these subjects that are definitely worth stepping into, especially in the current times where attacks are on the rise, and within the COVID context, they, as far as we see, don't plan to stop. Here is the link to the tools, so please download them, resourcessecureacademy.com/tools. And of course, do not forget to check our blog where we share different case studies, stories, tools from our experiences, from our projects. Make sure that obviously you're gonna join our online trainings. So here we go. We do run the live virtual classes where we teach advanced forensics and also advanced penetration testing within our Teams knowledge and Teams tools as well, and so on. So absolutely, please verify, check on that one. And if you guys have any questions, please do not hesitate to contact me at paula@secure.us. Thank you so much for listening, and as always, have a great day.